So, Mash. You want to learn Mash. Let's learn some Mash. First of all, you got to know you have to be in animation or in your FX menu set where Mash will become available to you. I'm going to create this tear off. I'm also going to open up this Mash editor. Very handy for when you're working with Mash in general. We're going to start by making a cube Mash network. You'll notice here that we have two types of Mash networks. We've got a mesh and an instancer. Mesh, you can do coloring and you can animate slightly differently. They're also individually addressable objects. Instancer, they are instance objects, so you can't color them and you can't animate them kind of weird. And you can't address them individually. So typically, instancer can be a faster object, especially for when you are rotating in your transform view, or I should say in your viewport. But mesh is kind of, I don't know. I like mesh. So we're gonna go with mesh. You can check mark this name on creation if you want your mesh networks to always be named one after another. We've got various distribution types we'll go over right now. I'm going to call this cube mesh distribution. So, first of all, number of points. If you go distance in any of these axes, it goes to the corresponding direction in the axis named. So, we will start with a linear distribution along this axis, x, with 15 units. We can increase the number of objects uh, created along that axis, which we then have to increase the distance to support. Or if you want them to be all together touching, you can just subtract distance to make that happen. So linear in that case. That takes care of distribution. Let's talk about rotation. It rotates, but it doesn't rotate them all uniformly. It rotates them all over a linear distribution style. So this last one gets the full 58 degrees. Let's call that 60 degrees of rotation. And everything in between there and zero rotation gets a percentage of rotation of that rotation. So number 5 here would likely get half of 60. So this is probably a 30-degree rotation right here. Same thing occurs in the other axes. Scaling X, Y, and Z all occur in a similar fashion to rotations, in that they all rotate, or they all scale according to a percentage along which this is distributed. So we start with 0% out here, 100% of the value is applied to the last object, and a percentage of which is applied based on these ramps here. So if we bring this ramp down and make a different distribution style, you can see that 100% of the ramp of the scaling is done at the end of the ramp here. And down here, 0% of the scaling is applied. You can then play around with these values by adding or subtracting your tangents. Cool little system. Same thing applies to a bias ramp. This applies the positioning of your distances. And the same thing occurs whenever you have rotation. Radial distributions have to do with circles. They can either go in that direction, or this direction. The radius, of course, is from the center to where your object is placed. The angle has to do with the amount of the circle that is produced. 360 being a full circle, 0 being none whatsoever. 180 doesn't actually give you 180 degrees of rotation because when you, as evidenced by us going to 360, they allow for this gap between these two. And so when you put in 180 degrees, you expect a half circle, but what you really get is half circle minus a square, basically. The offset, if we put this back to 360 degrees, has to do with the Z, the kind of forward direction that the mash is facing. So in XY, it's facing in this general direction. And in YZ, it's facing 90 degrees this direction compared to the previous version. And with ZX, it's going in an upward direction. Calculate rotation is handy for automatically rotating based on where it is in its radial distribution. We can see the difference between the two here. Notice they are all pointing towards the center point of the circle. spherical. It's a little easier to visualize if we increase the radius, increase the number of points a lot, and you can start to see that the shape of the sphere is evidenced by the points. You can also tell that this is actually based on geometry since we have a bunching of points down here when it is scattered. You can tell it to not ignore ramps and get some very interesting visual effects. Here we have all of our previous ramps going in a very exaggerated distribution. Animation speed and time is not what we're going to be talking about. We will not be covering any animation specifically, so we're going to just kind of move on. Mesh is where things get most interesting, in my opinion, for Mash. Love mesh distributions because if you take your mesh and let's give it a little bit more oomph, a little more divisions, so to speak. Two, that seems good. Go back to our distribution, take our torus, put it into the input mesh box. Didn't work. Okay, try it again. And I am just middle mouse dragging this. I'm not sure exactly why it's not working. Shabam! Now it's scattering across the surface. Alternatively, you can have it apply to vertices or to face centers, although you will note that you should probably increase this number to something pretty radical. I said radical. You can also work on edges. And all this is doing is aligning these mash points to the component that you have chosen. Alternatively, you can do randomized vertices, and you get a nice randomized effect. This also can work on faces. However, there is no... Never mind, there's the random edge. You'll notice with face center, you can push along normals, which can create some interesting effects. Let's see. You can also create a selection from create sets quick select. We'll just name this one set for now. This will take us to the next distribution type, which is not listed yet because we have nothing put in. Take your quick selection set, drag it into selection set, and suddenly we have the option component selection set. This will force only that selected component or those selected components to have Mesh Network associated with it. Very handy if you don't want your entire object to be covered with Mesh goodies. Moving on, we have voxels, which are representatives of the shell, the interior volume. As you can see, the purple are the various voxels. I think we'll just hide this so you can see what's happening. Voxel size refers to the density. Well, refers to the size of the actual voxels, which in turn refers to the resolution that you are getting, in a sense, basically. You can have both if you prefer. You'll notice that this is a totally dense mesh of voxels, whereas with the fill only, it's slightly diminished, and with shell, you can actually almost see through it. Voxel container is a little weird, and I will cover it on another video. Maximum voxel count just limits you to the amount of voxels allowed to be created. Notice if we cut that in half, we get half of a torus. That won't always work, but that was a really nice visual. UV space is an interesting one in that I have no earthly idea what it's referring to with UV space. It's sort of this undetermined term that really isn't helpful. If we look at our torus's UV, we unhide it. We notice it's just a plain, grid. And if we put this into UV mode, select them all, and expand them, nothing actually happens. So I don't understand this, but it gives a nice distribution that is fairly akin to the scatter distribution. So, I mean, use it at your own discretion. So, Let's move on to grid. I'm going to delete this torus. Grid simply creates a grid distribution. Uh, it's worth noting that ramps don't work with grid because it's just rigid and not very. Doesn't like you. It wants to do its own thing. So we're going to increase these to 10. So we have this to work with. Yay. Alternatively, you can also increase the number of y-axis grid whatevers. Fairly simple one. Ramps don't work, so we're not going to worry about it. And move on. The last one to really talk about is volume. This has very few controls. You've got volume size, speaks for itself, so to speak. Got a sphere, which is handy, and a point. Mostly, you'll be using these for dynamics, or in the case of what's another one? Oh, explode node. That's also pretty useful for that. So, but generally speaking, it gives you a nice kind of just generic sphere or cube of just goodies. If you don't want to bother making all the polygons and associating a voxel thing with that, this is a fast way to get a cloud of mesh points. Hurrah! Okay, moving on. Yeah, I want to talk about this. This is called a mesh waiter. This is where you'll find all of your various nodes that you can add and make fun things with. So we've got, I guess I won't get into those yet, but this is where you go. You click on it. It says add curve, and then it adds curve. Just know that this is the waiter. That's how I'll be referring to it in the future. This is called the repro node. It is associated with the repro mesh. If you put in another object by creating one and middle mouse dragging it, into the objects area, you find that nothing happens, but you can quickly create an ID node that we'll cover in more depth at another time and get an assortment of various items. So, in short, the repro node is where you go to find all the little details about the objects in your Mesh network. Yeah, right. So, there is another version of this that we did not go over yet, so let's quickly do that. I'll take my cube and my cylinder, and we'll create an instancer network. There are a couple things to know with this. Instancer, because we can. Let's go ahead. It behaves very much the same way. If you click on your instancer, lovely. You can see we have our two objects that we created it with. Pro tip, if you select multiple objects before you create a mesh network, it will put them all into your collection object, whether that's the instancer or the repro node, all at once, so you don't have to add them in after the fact. You can then go and add an ID node as before, and it will distribute with your multiple items. Quick note. Nope, no quick note. So instancer behaves basically the same way. It's just computed differently. It can be faster. It often is faster. However, it has been noted in the longer video that I did on this subject that using an instancer is actually slower in the viewport when there are many items than using a mesh distribution or a mesh network. Not sure why that's happening yet, but if you're experiencing many slowdowns, I would recommend go ahead and switch over to a mesh geometry. And to show you how to do that, you select your instancer. Under utilities, you can go down to switch mesh geometry type. You will now be greeted with a really. Select the mesh waiter that you want to switch, go to utilities, and switch mesh geometry type. You will now be greeted with a repro mesh instead of an instancer, and the familiar little doodad here. I think that's going to do it for this episode. So thank you for joining me. This is Running Through MASH. So fast, I forgot to do the intro. So I will see you next time. Bye-bye.